This is video 4 of topic 2. Here we'll talk about extreme weather and thunderstorms and an introduction to precipitation. Thunderstorms are characterized by cumulonimbus clouds, and they produce heavy rainfall, thunder and lightning, and hail. They result from strong vertical movements in the atmosphere, typically in spring and summer. They require unstable, warm, moist air that releases latent heat when it's lifted, which provides buoyancy that's needed to maintain upward motion into the atmosphere. There are 3 stages in thunderstorm development: cumulus, mature, and dissipating. The cumulus stage, which is the first one, is where moist air rises and cools, and then it condenses into a cloud, beginning at the lifting condensation level, which we learned about in a previous video. The cloud grows taller as air condenses at successively higher levels, so you can see it growing here, and as it grows beyond the freezing level, the cloud is composed of both raindrops and ice particles, and that ice then helps further growth of cloud particles. The storm cell diameter begins to grow, and it grows from about 1.5 kilometers all the way to 10 to 15 kilometers, and vertically it will grow about 8 to 10 kilometers in height. Eventually, the rising air cannot retain water droplets, and so you begin to get rainfall. That brings us to the second of the 3 stages, the mature stage. This is where large water particles, or hail, begin to fall. And this is because the droplets eventually are too large to be supported by an updraft that occurs, and then those droplets fall as rain. As the rain falls, drier air which is near the cloud, next to the cloud, begins to be drawn in. This is called entrainment. The resulting drying of air evaporates some of the rain droplets, and it cools the air. Remember, evaporation is a process that requires energy. So you go from liquid water back to water vapor. That takes some energy from the cloud and from the storm. This colder, denser air that begins to be created begins to descend as a downdraft, and you can see that in this figure here. Here's the entrainment process. Okay, it begins to descend as downdraft, which eventually reaches the ground and spreads away from the clouds. And these are the cold gusts that you'll often feel during a thunderstorm. The upper part of the cloud, up here, still has a strong updraft, and it finally reaches a stable part of the atmosphere very high up, where the high altitude winds, up here, may create an anvil shape. So this is where the cloud has actually entered the stratosphere. And by this point, the cloud may be as high as 12 kilometers, and so the storm is now characterized by lightning, turbulence, heavy rain, and possibly hail. Okay, so that's the mature stage. Eventually, the downdraft spreads over the entire storm cell and it cuts off the updraft. That begins the dissipating stage. Updraft is critical. It provides the moisture that's necessary for cloud development, and so when it's cut off, the cloud begins to dissolve. Further, as the rate of precipitation diminishes, the downdrafts also gradually decrease, and then the cloud dissolves, and that's the end of the storm. Now, we're interested in thunderstorms because they produce very large amounts of rainfall in a short time. Okay, so that's the hydrological perspective. That's why they're important. There are other forms of extreme weather that are also hydrologically interesting. So I'm sure you've heard of tropical cyclones and hurricanes. These are intense cyclonic storms, and they form over tropical oceans between 5 and 20 degrees of latitude, so close to the equator. And they form typically in the late summer when the water temperature is high, about 26 degrees Celsius or warmer. The number does vary annually, so there can be between 3 and about 12 hurricanes per year. These are the named hurricanes. And this was the historical average between 1950 and 1990. They're important because they produce extreme rainfall and very high winds in some cases. So there have been winds that have been clocked at more than 300 kilometers an hour. Those are extremely damaging, obviously. In East Asia, they're called typhoons. In India, they're called cyclones. and in North America they're called hurricanes. If you want to see more about them, there's a good video here from National Geographic. You can check that out on YouTube. And of course, we do classify hurricanes. So you may have heard of a Category 1 storm or a Category 2, 3, 4 hurricane, or maybe the most catastrophic, a Category 5 hurricane. They're classified according to a scale that's based on the central pressure, the storm surge height, and the wind speed. And as I said, there are 5 levels. A storm is officially a hurricane if the wind speed is greater than 73 miles per hour or 119 kilometers per hour. Storms with lower winds of less than 61 kilometers per hour or 39 miles per hour are called tropical depressions. And look at the effects here of the different categories. So a Category 2 storm has wind speeds of up to 110 miles per hour. They do some damage, and so some roof, door, and window damage is done to buildings. Some trees may be blown down. If we go to a Category 4, which is the ones they start talking about in the news much more, these have wind speeds of up to 155 miles per hour. The damage can be extreme. So you can have extensive curtain wall failures and some complete roof failures, shrubs, trees, and all signs blown down. And then with Category 5, which is the really catastrophic category, you can have complete roof failure and some complete building failures. These are very high winds of 250 kilometers per hour or greater. Okay, and again, we'll see more about these in the next topic. And I should mention, we will come back to talk about the climate as well. We'll talk about this as the last unit of the course. Okay, so we'll talk about climate change in some more detail. This ends video 4 and topic 2 of the course.